This is Orsi, official old guy at oldguytalkstome.com, a podcast dedicated to helping older guys create kick-ass lives for themselves and those that they love. It's for women too. Each week, I bring you a special guest to help you create that life that you imagine for yourself and those that you love. We talk anti-aging medicine, personal growth, relationships, and sex, vices, and other topics that many don't want to talk about but need to. Just because you're getting older doesn't mean you have to be old. Also, if you want to know 3 ways to get laid more frequently without begging, go to oldguytalks.com and opt in. When you do, you're going to get my informative video on 3 simple things you can do to get laid more frequently without begging, so you don't have to turn in your man card. And ladies, you may want your man to know these things, because I think you'll like it too. Additionally, you'll be notified weekly when a new podcast episode is ready for you to consume. Periodically, I will share with you other stuff that will help you create that life that you want for yourself and those that are important to you. Don't want to miss anything? Be sure to subscribe, share, and review this podcast. Did you know that there are 76 additives that have been approved by the FDA that can be added to wines? You want a wine with shit in it that may not be good for you? Well, there is an option for wines that have been produced naturally, organically, that have been tested, that have no sugar. And when they don't have any sugar, that means that they're ketosis and intermittent fasting friendly. These wines have been produced with a great deal of care on small farms and are available to you. How do you get them? Find out by going to www.oldguytalks.com/dry farms, all one word with an S, and find out more. And with your initial order, you can get a bottle for 1 penny. That's right, a bottle for 1 penny. And they taste great. They taste great. Don't wait, don't hesitate, don't procrastinate. Get those wines now. This is information only. Consult with an appropriate professional before starting any program. Do not be stupid. You are responsible for your own shit. The old guy is a capitalist and not a socialist weasel. He will be promoting stuff here and may be compensated. You can rest assured the old guy only promotes stuff he uses. You may have different results. This is Orsi, official old guy at oldguytalkstome.com, a podcast dedicated to helping older guys create kick-ass lives for themselves and those that they love. And part of that journey has to do with your health. And we're going to talk about something that's, you might have heard a little bit about, called exosomes. And I have a Dr. Duncan Ross, Ph.D. He is he's an immunologist, and he graduated from Professor Robert Levy Laboratory at the University of Miami with preliminary work in biochemistry and molecular biology. He's published in Blood and the Biology of Blood and Marrow Transplantation, as well as Protein Expression. Dr. Ross's current focus is developing cell-free exosomes-based therapies via Kimera Labs in Florida. Dr. Ross has concentrated on the development of quality-driven 27,000 square foot facility in Miami, Florida, staffed by 40 Floridians and dedicated to the production of exosome candidates for the treatment of human disease. Now, I got to tell you that Dr. Ross is one smart dude, because when I checked out his LinkedIn profile, I had to look up what some of the words meant, like togocytosis and yeah, I can't even pronounce it right. But he's got a lot of stuff going on there, and so we're going to try to simple it down. Now, when I've seen him lecture, sometimes I'm not sure exactly what he's saying because he uses words that I don't know. So we're going to try to simplify some of this stuff for our audience today. So thanks for coming on board, Doctor. So I usually ask this question of my guests: what's the most important thing you've done today?
Well, I have a pretty interesting old guy in the other room. His name is Louis Frisina. He's my CFO, and he has had an interesting life. I mean, there's a company called Fisher Scientific, and so you understand how big that company is. Most of the stuff we purchase for this lab is purchased from Thermo Fisher. So he was the CEO of Fisher Scientific at one point. He also was the first guy to bring facial fillers for women into this country. And he, he said, yeah, when I was at Fisher, I had 2 planes and a helicopter that I had access to, So he's just so cantankerous and funny that I just enjoyed hanging out with him. So we went over some things. That was probably the most important thing I thought today.
Okay, great, great. So just as an overview, what are exosomes and what is the history of exosomes?
Exosomes are, and that's what that word trogocytosis meant. For many years, people have been trying to figure out how cells communicate. Does the cell do it? Does it actually stick out a finger? Why do we sometimes see 2 cells merge into one? And what is the point of that? What is the reason for that? And so people saw that there were these little clumps coming off of cells for a long time, and they thought that they were just trash. They thought that that's how the cell got rid of, misfolded proteins or things to that effect, which is kind of a weird thought because, cells are able to break down proteins. Wouldn't you want to just reuse that stuff, be it nucleic acid, be it protein, whatever? So over the last 10 to 15 years, people have started to realize that exosomes are the way that cells communicate with each other, and you're sending messages in these little vesicles. And these vesicles are the size of COVID, by the way. They're very, very small. And so they're therefore also very hard to research, right? Because you can't see them with regular sort of hardware. So people started to realize that, it wasn't the cell that was really doing the work here. It was what the cell was secreting in the form of these exosomes, which are these small lipid balls. And so I noticed that in 2014. Other people had noticed it earlier. But then I thought, well, I can really turn this into a therapeutic and not need the cells, which are very difficult to transport, keep alive. They can easily get contaminated because a cell is the same size as a bacteria, right? So if there's a contamination in there, how do you get it out? It's extremely difficult. But an exosome is this big as opposed to a cell, and you can sterile filter it and make sure that you have a clean product. So this is how we're able to bring regenerative medicine to the masses in a sterile fashion without hurting anybody. And that's been the most important thing.
Yeah. So you talk a lot about these cell-free production. How are they produced?
They're produced from cells. We grow cells here in the laboratory.
Okay.
But then we separate the exosomes from the cells and sell that separated exosome solution.
Okay. Now, there has been some controversy around exosomes, and there's the FDA wrote a paper and things like that. You spent a lot of time interacting with the FDA, from what I gather. Can you kind of comment a little bit about what's going on in the whole industry of exosomes?
Well, the funny part about that thing that the FDA wrote is that in this unregulated area, anybody can write the word exosome on a vial, and then you would think it's an exosome, right? When it's not an exosome, they're just trying to capitalize on that word. So in the case of the people that were contaminated, I know this story so well because I was selling exosomes to that clinic prior. Then they switched to a new provider that their owner owned part of, and within 2 weeks had contaminated 6 people and sort of gave exosomes of that name. Now, I know that I told you it's semi-impossible to contaminate an exosome because you run it through a sterile filter. There's no way a bacteria can get through that. These people were selling basically parts of cells or ground up fetal tissue, not fetal tissue, but placental tissue, and diluting it and putting the word exosome on it and selling it. That's why they hurt these people. The only reason that nobody went to jail in that case is because they had actually sent it out for sterility testing, and the lab that tests it gave them the wrong answer, told them it was clean. So, but the fact, that's why they didn't get in trouble. But the fact that it's even possible is what the FDA is worried about, that these people will go out there and just say whatever the hell they want and then end up hurting people. So, yeah. That's what happened in that particular case. But that's what something I try to explain in my talks is that exosomes are not dangerous. The people that say that they're making exosomes are dangerous, and it's very hard for you to know who to trust.
Yeah, it really is, especially if you're a patient or a consumer or even a practitioner, prescribing exosomes to your patients. What can exosomes be used to treat?
Well, they can probably be used to treat anything, and certainly there are many companies investigating different types of therapies. There are some investigating cardiac disease. There's some investigating, longevity. I believe that Jeff Bezos just invested in a company that's going to be doing that. They're very, you can make, and that's the hard thing to wrap your mind around. Even bacteria make exosomes. There's thousands of different types of exosomes. They can be used for different uses. So we know they're immunomodulatory. They can suppress inflammation. That could be good for multiple sclerosis. But you could make a different type of exosome from a different cell that could actually regrow that myelin sheath that's around, that's in your second progressive part of multiple sclerosis. So that's super exciting to me. And we're working on 5-6 different types of exosomes we want to take through the FDA. The one we have now we know is anti-inflammatory, so it's good for those types of uses. But we're working on other ones that are neural specific, and ones hopefully that will make you live forever. There's a physician out in LA who has this fantastic idea for how to target those exosomes to try to convince your body to be younger. And I'm very excited about that.
Yeah. Now, do you have products that also treat things like burns and hair growth, and also are there any benefits for cancer patients of exosomes?
Well, burns is the main thing. That was the first thing. The first patient I treated was a burn victim. And what's nice about that is that they've lost their epithelium, and so it's very easy for the exosome to have an effect. So that's a good use for them. It's good for scarring, because scarring is really caused by inflammation. So if you can stop the inflammation and get the skin to grow, so let's say you have a scar, you can remove that scar, place the exosomes, and then the skin will grow back normally because you stop that inflammation. So that's a good use. We're working on a hair IND as well. I've actually started sending out quantification devices to people so that we can see what the results are there. Now, cancer is a complicated one, but there seems to be research that if you have a deficiency, I met a professor at the International Society of Extracellular Vesicle meeting in Barcelona like 3 or 4 years ago. God, life was so fun before COVID. Getting to go to these.
Yes, it was.
Great. And I wish we could just get back there.
But be thankful you're living in Florida, and I'm thankful I'm living in Las Vegas, not New York City.
Oh man, right. It is crazy, the difference, because I go to Vegas a lot on my way to LA when we go back and forth. And really that was the first place that I got to walk through a casino without a mask on and feel like I was back in the old days,
Yeah.
But anyway, so I met this professor, and he was working on, he works on acute myeloid leukemia, which is actually what my dad died from. So I thought that was interesting. And he uses exosomes, and he can show that the AML will stop growing in vitro in a dish when you add back regular exosomes. Now, how is that happening? It's happening because you get cancer because of deficiencies, right? And so if you lose a regular function and you lose pieces of that cell, you can replace it. And when you replace it, that cell will start functioning normally. Now, it's not going to stop sort of the underlying reason that you have cancer, but it may allow you to slow it down, right? While you come up with some other answer. So like in the case of, there are genetic treatments for sickle cell anemia now, right? So if you replace that gene with the viral vector, you can cause the red blood cells to start being expressed normally, right? So if you can think about it like that in the future, you will have exosomes that can sort of pause the cancer while you create sort of a viral vaccine or something like that effect. So you can cure the cancer. That's pretty useful.
Yeah. In the administration of exosomes and regeneration, is in some situations there's a delay in terms of the actual result. Is that correct?
Right. I think regenerative medicine takes a while. Inflammation can be stopped immediately. Regeneration is going to take a while. And the way I say it is that if your body takes 9 months to gestate when you're a fetus, why would you expect something to move any more rapidly than that? There was a talk that was displayed at Toby a few years ago, which is an orthopedics conference. And they were talking about the Mayo Clinic and their use of bone marrow for the treatment of degenerative disc disease. And they had 2 patients up there. And the first one was a woman who said, well, I got my first treatment and I didn't feel anything. And I was really angry because I thought they stole my money. And then 8 months later, my pain started to go away. And then the next patient was a gentleman who said, well, I got my first treatment and I felt good. But then I came back for a booster and I felt bad. And what he meant was that, I think, that by treating that with that bone marrow, you stop the inflammation in his disc. But then by coming back with the PRP booster that they probably did, it caused inflammation again, because PRP causes inflammation. And then they, hurt him. Now, what would have been interested to know is like to see him now. Do you still have that pain? Right. I am going to guess that he doesn't have as much pain anymore. But it takes a while,
Okay, that's interesting because PRP's been around for a while, and it's interesting. Actually, when my background is I used to be a periodontal regenerative surgeon, and the first time I used PRPs was in 2000 to do grafting procedures.
Oh, wow.
It was quite a while. Actually, they didn't have any PRP machines then. You actually had to use the old hospital perfusion machine, which was about the size of a small washing machine.
Wow. We will make exosomes for other people. That's what we do. We're manufacturing. And so I have an Ivy League school wants me to make them a gingival exosome. So
that's interesting. That's interesting. So if you're a patient out there, how do you go about finding a doctor or a practitioner that's well trained and making sure that he or she are using good quality exosomes? How's a person actually do that research out there, or how would you recommend they go about that?
That's a good question. There's a lawsuit which everybody's paying attention to right now, which is with a group called the Cell Surgical Network. They, I don't know if you've heard, something called stromal vascular fraction. People were doing a lot a few years ago, and they'll isolate the stem cells from fat and then use those. And those stem cells are certainly anti-inflammatory, and they're good for a lot of things. But a few, how do we say? A few non-educated practitioners, and the scary part is they weren't even practitioners. They weren't an MD and they weren't a PhD. They're just somebody who maybe worked in a lab once and decided to start telling people she was going to do regenerative therapies. And she injected these cells into both eyes at the same time, which you never do if you're doing an eye treatment, and blinded a couple of patients.
Wow.
And I'm fairly certain that the reason she blinded them, this is just my opinion, is that when you use an enzyme, you use collagenase, an enzyme to break up fat. When I started doing that, the amount of collagenase you need to use for 60 cc's of fat is so small you can't even measure it, because your what do you call it? Your scale is not that precise. So I have a feeling that she just probably put 2 orders of magnitude too much collagenase in there. And then her protocol for getting rid of it was wrong. And then she probably injected collagenase in these people's eyes and it digested their retinas, So that's what the FDA is afraid of. You can't give these, yes, maybe it's true, but you can't give these tools to people that are not educated to correctly use them.
Mm-hmm.
And that's why they sort of ban that, right? That's why they're banning things like what you would call Wharton's jelly or umbilical cord cells or whatever, because yes, theoretically that could work, but people do it wrong. Like the clinic where they contaminated those 6 people. That happened before with umbilical cord cells. Why? Because like I said, it's hard to keep them sterile. People think that what comes out of the sterile field in an operating room is sterile, and it's not even close to sterile. I mean, there's no way I could grow things in that environment. They would all get contaminated.
Mm-hmm.
So that's the real issue here. Not that the science is wrong. It's that it's semi-impossible to find somebody that can do it correctly, and you're sort of rolling the dice. So sadly, that is why you need regulated products. And I filed an IND with the FDA for the treatment of COVID. And they're asking me for all kinds of interesting tests. They even want me to put the cells into animals to make sure that the cells don't kill the animals, not the exosomes.
Mm-hmm.
But we don't sell the cells, but I still have to do this testing. But they do make you do those rigorous kind of characterizations of the product, and that's what you want. That's why you want something that's FDA approved, because you want it from a provider that's not going to kill you.
Mm-hmm.
So I mean, and that is coming. Like I said, I have my IND in. Other companies have INDs in. These trials are starting. So I think it's just a few years now. I'm talking a couple before you start having approved exosomes for certain treatments.
Okay, well, that's kind of interesting. You just mentioned you got something going in for COVID, to treat COVID. And what's that?
Well, we have we were trying we have acute COVID and we have long hauler COVID. And acute COVID, what we're trying to do is, if you start to have what you could think of like a sepsis, a cytokine storm, an overinflammation, right?
Mm-hmm.
We could stop that prior to you maybe needing to go to the hospital and then be intubated, etc. So that was the goal on acute COVID. With long hauler COVID, we've found that what do you have problems with? You have continuing pulmonary issues, you have tachycardia, you have mental fog, this type of thing. So that was what we're going to assess in the long hauler population. And I hope that we could start that by the end of the year.
That's the first time I've heard the term long hauler COVID. I don't think I've ever really heard that. That's kind of a...
People are starting to say it more often, at least the people I work with are.
Okay, because that's a very interesting situation. And what's the and so you're
actually, I think the NIH is calling it that because they put out a call for research into it. They want, yeah.
That's I find that very, very, very interesting. Are there any contra?
Want to hear something funny? So I was just in my bookkeeper's office, and she can grab her hair and like pull off whole chunks. So everybody who got COVID is losing their hair now, and women around the country are very freaked out about it. But that's going to stop, right? It's only going to happen for a few months. But if you can get the word out, these poor ladies, they think that that's it. They're losing their hair for the rest of their life, but it's just a side effect of COVID. It's basically like a long hauler syndrome. So can we stop that by using exosomes? I mean, these are the type of things you can look at.
That's very interesting.
Let me ask you a question.
Yes.
That group that I told you was famous for the stromal vascular fraction. Now, they're in this lawsuit. They do know how to do it, right? I said that some people didn't know how to do it and did it wrong, but this group I do believe can do it correctly. So they're in a lawsuit with the FDA about the right to be able to do that. But one of the things that he said, and one of the dangers, is that this one time this woman had just come with recent dental work, and I guess it was infected, and he treated her, and he suppressed her immune system, and the woman ended up losing the whole side of her face. because that infection just took off. So how often do you see that kind of thing?
Quite frankly, I mean, I've dealt with infection for over 33 years. I never saw anyone lose the side of their face. I mean, that's like, that's just like from a dental infection. Oh, I mean, you know, maybe it's because people come in, they're so in so much pain they get treatment. But that's a raging infection, or that's a lot of suppression. Because literally, I've never. I mean, you may lose bone, part of the mandible or maxilla, things like that. Yeah,
Lost skin and bone.
yeah. That's just absolutely that's incredible. That was the effect, because generally, you know, usually the results of a dental infection are pretty limited to a certain extent. Of course, there's some systemic effects there too, but most of the time they're just limited to the direct region that's there. So it's kind of an interesting thing. So, yeah. So you talked about dental work. Are there any other contraindications to?
Well, cancer is a contraindication, right? Because you have something called tumor immunosurveillance, right? So we're getting cancer all the time. But the cancer starts to rearrange genes such that proteins are made that don't look right, and the cells display those proteins, and then your T cells kill the cell. So, like I just said, if you immunosuppress by giving these regenerative medicine therapies, you could stop that tumor immunosurveillance. And the same thing happens with herpes. You can have a herpetic lesion outbreak, like a shingles, solely because you gave that anti-inflammatory product.
Mm-hmm.
And so that's it's something to be wary of. Further, if you're going to, you know, incite or instantiate is the right word, regeneration, then that could also push a tumor as well. So that's why the cancer situation is so touchy. You know, you really have to know the cytogenetic profile of the tumor before you consider working on it.
Mm-hmm.
You don't want to make it worse.
Yeah. The
like when people have cancer, my first thing is go out and get a vaccination. I don't care what vaccination, HPV, herpes, whatever, or shingles. You're going to raise the inflammatory state of your body, which will improve that tumor immunosurveillance, which may, you know, help you out in the long run.
Oh, that's an interesting thing. When you talk about various modalities for regenerative medicine, stem cells, exosomes, peptides, things like that, how do you see when to use what in terms of your recommendations to practitioners? What do you say to them?
I don't say a lot anymore because they're the artists, right?
Mm-hmm.
I just make a product because I know that they have all these different modalities that they use to achieve a goal. They might not know why it's working, but they've seen it work before, right?
Mm-hmm.
I'm desperately trying to find somebody who can explain to me how thymosin alpha-1 works because I'm so tired of hearing about it, right? I get tired of hearing about how ozone does all these magic things. It doesn't do magic things. It breaks up cells just like hydrogen peroxide would. And when the body sees what's called necrotic cell death, cell pieces, it upregulates an anti-inflammatory cascade. So that's why you get that anti-inflammatory response from ozone. It's not magic, right? There's been a lot of literature about that type of therapy. It was called extracorporeal photopheresis. It's been used in bone marrow transplantation for the last 40, 50 years.
Mm-hmm.
So they will use ozone with peptides, with exosomes. They'll do all these crazy things, but they end up getting the outcome that they want. And so I have tried, trust me, to say, do this exactly, do that exactly. And it's impossible. They're going to mess around until they come up with something that they see working on a patient, and then they're going to repeat that.
Mm-hmm.
So all I like to say is that exosomes need a matrix. That's what I know. You can't just throw exosomes out into, you know, midair and expect them to do something. They have to have something to hold them in place and for cells to crawl out across. There's a product called A-Cell, which is approved by the FDA. It's micronized pig bladder, but it's irradiated, and so it's not dangerous. But there's this video on YouTube where the guys, you can see his finger growing back because, you debride it, you put the matrix on, the cells can crawl out, but they can't crawl out into midair. So the matrix is just as important as the exosome. And that matrix can be PRP. Wharton's jelly was a good one, but again, you can't keep Wharton's jelly sterile. If Wharton's jelly is irradiated, then that's fine. But nobody was doing that. So you can irradiate it and then get it approved by the FDA, and then everybody's happy with that matrix.
Oh, okay. Now you have a product that an exosome, XoGlo. What is that?
XoGlo is a placental mesenchymal stem. It's funny because everybody here, they're all Latin, a large portion of them. They all say XoGlo, right? And it's XoGlo.
Okay, XoGlo.
It's a placental mesenchymal stem cell exosome. And the reason that we use placenta is because it's very anti-inflammatory. Wake Forest uses placenta cells. They're a special type of cell because they're the only organ that has to not reject a third party, right? So that's why we use those. We create that 120 nanometer particle, and then we assess it for microRNA, messenger RNA, sterility, all that type of thing. And then, as I said, the first patient we used it on was a burn victim. I really wish I had more burn victims to use it on. I think the uses in any kind of topical wounding are really, really great.
So that's interesting. Where do you and how is that? How are exosomes administered? Is that through injection, or is that the most, or how?
Right now, it's just topical. You would need FDA approval for injection.
Okay, so it's all topical at this point. Okay.
The COVID IND that we're working on is IV administration, but we haven't begun that yet.
All right. So looking over into the horizon, into the future, what do you see as possibilities for what kind of exosomes are out there, or do you think are going to be developed to treat various diseases?
I'm excited because the one thing that I think about regenerative medicine and anti-aging is that I know there's a number of companies that are working on nanovesicles that use what's called Yamanaka factors to try to rewind aging. I mean, we know that you can take a skin cell, de-differentiate it, and then push it towards, say, a neural cell phenotype. We already know this. We know what the factors are. So I think there's like 10 companies that are working on bringing that type of a therapy to market, and it's going to work. And if it works, regardless of whether I make it or not, I still get to regenerate, right? Or I get to rewind my aging.
Sure.
Even if I'm buying it from them. So I'm super excited about that. I mean, I am working on the same thing. Jeff Bezos just invested in Mr. Yamanaka, so let's see what they're going to do there. But certainly they're going to have the funds to do whatever they want. But that's going to be good for all of us. You just hold on 10 more years, we're all going back to 30 years old.
Well, at least my gene pool is such that there's a good likelihood, even though I am 69 at this point. But my gene pool is, no one in my family's died of natural causes before the age of 90. Right. And they were all basically unfiltered cigarette, moonshine drinking people. So you can't. What's that?
Do they have COPD?
My father did, but it wasn't. My father actually, when they came to the United States, he worked in a John Deere factory painting tractors, and he didn't have a mask.
Oh.
Yeah, yeah, that was for sure. That was, it was the mid '50s. So I mean, that's, no one knew. Right. That kind of stuff was pretty common. Now, obviously, they'd be wearing masks. Well, they've probably got robots doing it anyway, so there's probably not a human within sight.
Yeah. Did you see that new little? You know those decorative pots? There's a new FDA warning that they have 10,000 times the acceptable limit of lead in them, And I was like, who actually uses those things to cook with? You know, I mean, they're pretty. Put them on the shelf. You know.
Yeah. No. And I suspect they're probably made in China too. It seems like everything's made in China these days. All right. Well, Dr. Ross, I want to thank you very much for coming on the program and explain this whole world, this exciting new world of exosomes and the possibilities that exist and what is available today and what is coming on into the future. Yeah. So it's very, very nice. Thank you very much. This is Oris, the official old guy at oldguytalkstome.com. Remember, I want you to do several things. I want you to share, review, and rate this podcast. And if you're going to give me a bad review, that's okay. I don't mind it. I love my trolls. I like to feed them and reply to them because they're wonderful people and they boost my rankings. Until next time, thanks for joining me on this podcast. If you like what you heard and learned, then be sure to do 3 things. 1, subscribe so you don't miss the next episode. 2, share this with someone who may need to hear it also, and it may be your significant other. And 3, review it. Give me a good review. If you didn't like it, give me a bad review. I don't care. Just review me. And be sure to get my free video on 3 ways to get laid more frequently without begging. Opt in at oldguytalks.com. Don't be that guy that just takes in the information. Take action. Without action, you're not going to get the results you want.